Okay, so actually I was learning machine learning, and inside machine learning I get a topic that is linear regression. Okay, so I want to share my idea, actually what I have learned, in easy words. First I will work with fewer data, and then I will work with some bigger data, and I will use Python for that. Okay, so if I make that easy, or what I have understand, that let's say I am a student of physics, let's say, or actually I am a student of triple, but let's say I know the physics that the equation of falling body looks like this. Okay, so I know that the velocity and the time, this relation is actually linear. Okay, so I want to test that, and to do that I went to the building, and then I have fall the ball and take some time, let's say 0 1 2 3 4, and I have collected some data of velocity, and then I have plotted that to the time, to the velocity versus time graph. And as this relationship is linear, so I can expect that this line should be linear. That means I can draw a line. But actually in the practically there might be some mistake in my measurement, or there might be some air friction, or there might be some anything, so my data will not look so perfect. So rather my data will look like this. That means I can draw a perfect line among these points. But what I can do, that I can approximate a line. That means I can make a line for which the deviation is minimum. That means the distance from this point to this line is minimum. That means I cannot make the deviation 0, but that's not the problem. I have to make this deviation minimum. If I draw this kind of line or this kind of line, you can see that this line is so much far from these points. So let me erase this thing, and let me find the equation of this. So we know the equation of the graph looks like this, and here x is actually t, and y is the velocity v. So I have to find this m and the intercept of this line c. So somehow if I find m and c for which the deviation is minimum, then I will find the line. So first let me find the line, and then I will tell you that what is the benefit of this line, what I will obtain from this line. Okay, so let me find the line. So this is VS Code, and I have installed the Jupyter Notebook extension here, so I can use it like Jupyter Notebook in this VS Code. You can also do this. I love it. So first I have to import numpy as np, and then what's wrong here, numpy, and then I have to plot that. I need import matplotlib.pyplot as plt. Okay, now I will make some point. Let me first take some smaller point. So np.array, let's say 0 1 second, 2 second, 3 4 5 second, and let me make some velocity which I have obtained from the experiment. Let's say 4, then 15, then 25, then 32, then 48, then 52. Okay, now if I want to plot this thing, I mean plt.scatter and x comma y. So let me see what happens here. Oh sorry, no, x comma y, t comma v. So if I plot this thing, so you see this plot is not quite linear, because you cannot draw a single line between these points. So what I can do, I can make a line for which the deviation will be minimum. So let me do this thing. So to do this thing, I need from sklearn module, sklearn.linear model, I will import a class, and the name of this class is linear regression. So basically linear regression is a class. And I will use this linear regression class, and I want to make a model. I want to make an object, and the name of the object I will choose LR, that means linear regression. And inside linear regression object, I have a function fit. So basically this fit is a function, maybe, yeah, this is a function, or actually this is called method. Yep, same thing. And inside that I will input t and then v. So what this fit function will do, this will analyze the data, work on it, and it will give me the coefficient and intercept. So if I run this cell, oh, what's happening here? Some error, right? So how to solve this error? It is telling me that you have to reshape your data either using this thing, or what can I do if your data has a single blah, I can use this thing. That means if I write here reshape -1, 1, and then again run this, yeah, this works. So what I have done this thing, basically using that reshape function, my t was like this, and using reshape function I make that t like this. Let me show you what I have done this. So basically, let's say if I remove this reshape, and if I write here t, so this t is a simple array, right? And now if I write here reshape, and then if I write here t, and now you see that shape of this time. And if I now t dot shape, you can see that it has 6 rows and 1 column. Okay, so forget that. So now if I run this, you see my linear regression model is working, and now I need m and c. I need m and then c. So to find m, I have to, inside LR, I have a variable which is coefficient. So you see I have a variable which is coefficient, and also I have intercept. So I have found the value of m and c, and if you want to see the m, so this is m 10.02, and c looks like this 4.42. okay, so let me use this thing. Okay, so now let me tell you that what is the benefit of finding this m and c. But first let me draw that line. So how I will draw that line, I will take this line again here, and then I will use plt.plot. I will input time, and instead of this real value, real data from the experiment, I will use this line. That means m into t plus c. So I have used this equation, and now if I run this, so you see now my line is fitting. That means my line is approximately between these points, so deviation looks like minimum. Okay, that's good. Now the question is, what is the benefit of this thing? So let's say you didn't take the data of 1.5, but you want to know the velocity when the time is 1.5. So what you will do, let's say t, let's say you want to find. Okay, so np dot array, let's say 1.5, and I have to reshape this thing. So reshape -1, 1, and then inside LR I have a function named predict, and this will predict that velocity for me. So let me input t1, and you see the velocity is 19.47. So when 1.5, the velocity is 19.47. Let me work with another. Let me work with 2.2. So if the time is 2.2, and let me run this again, you see now the velocity is 26.49. let me check here at 2. Yeah, that looks like 26 from the graph. Okay, so by this thing you can do. Okay, let me do another thing. Let's say you just know the data from 0 to 5, but you want to know what will be the velocity at when the time is 10. So let me write here 10. So after 10 seconds you have the velocity 104 meter per second. So this is the benefit of linear regression. Okay, so now let's work with some bigger data. Bigger data means, you see, in this case I have only one input and one output, but now I will take a lot of input. My input will be age, my input will be sex, my input will be BMI of the patients, and my patients will be for 2 patients I will work with a lot of data, and I will have a diabetes output. So I have one output and I have here 10 inputs, and I have 4 for 2 patients. So where I will get this data? So basically I will get this data. Let me erase all the thing here. So I will get this data from sklearn. So sklearn.datasets import load diabetes. So you see this load diabetes here. Let me run this cell, and now let's see what is inside load diabetes. So load diabetes, let's write as frame true. That means I want to take that as frame, and then I want to return something from this load diabetes. So what is actually this? This is a function. So I want some data. So I want some return. So return xy, as true. Okay, so what I want to return, I return, and I want to load that in x and y. So basically x is the input and y is the output. So let me see what is inside x. What is this? I don't know what is this. Let me run this again, and now let me put here x. Okay, so now this is the thing. So x is basically the input. You see the age, the sex, the BMI. So you see the age is 0.03 minus, the age is minus. What is going on here? So basically let's say that you have some data from 0 to 65. I don't know what is there in the data set, but let's assume that you have some data from 0 to 65. So you can make this data, from -1 to +1. You can make that using means and standard deviation. You can do that. So what that load diabetes has done, that has made this range into this. So sometimes the age is -1, sometimes this, I mean the range is between -1 to +1. That means 0 to 65 has become -1 to +1, and that's why you can see that some age is positive, some age is negative. All the ages are less than 1. Similarly sex, BMI, BP, then these are some S1, S2, S3, and I am not a doctor. I am a triple student, so I don't know what the meaning, but that's not the problem. Because machine learning engineers don't need to all everything, but we can know this thing. Let's see. Okay, so I have gone some website, jigs for jigs, and these are the definitions of S1: total serum cholesterol, low density lipoproteins, high density lipoproteins, cholesterol, possible log of serum, blood sugar. Okay, good, sounds good. Sorry to say wrong, actually that has been scaled. Mean is 0 and unit variance. Okay, no, I think I didn't say wrong. Yeah, 0 mean, I have told that 0 mean, and unit variance, I mean that is actually -1 to +1 basically. So 0 mean and unit variance. Okay, so let's go from here. Oh, what is S frame true? So what this is actually doing, so if I write type X, so you see this is actually the pandas type, right? So pandas type, the type is pandas, but if I write here false, then you see this is actually the numpy type of X. Now the X, that means the input array, this is actually numpy array and the array. So let me work with numpy because it's easy. Okay, so let me work with numpy, and now let me do one thing, let me do something like professional. So what I will do now, you see I have many data. So what I have 442 patients. So now what I will do, I will take 80% of the patient to train my model. I will train my model with the 80% of my patient, and I will find the value of M and C. And what I will do with the rest of the 20% patient, I will use that 20% patient to test my model. So whether my patient is good or whether my patient is bad, I have to test that, right? Whether my model is good or bad, I have to test that. So how to test that thing? I will use 20% data, 20% patients data to test my model. Okay, so let me do this thing. That means we have to split this data. 80% is for train, and I will split that data such that 20% is for test. Okay, so let me do this thing, and to do this I will need a help of from sklearn dot model selection. I will need the help of import test train test split. So this is basically a function, and this function will, you see the name, it will split the data between train and test. Okay, so let me call that function. Let me input X and Y. Let me make the test size is 20%. 20% means 0.2, and random state, let me shuffle the data. So this is actually 2. You can take that whatever you want, it will shuffle the data, that means you know. And now let me go to the test train test split information, and if I go to below, you will see that this actually returns X train, X test, Y train, Y test. So this is the return value. So let me copy this thing by Ctrl C. I have a bad habit, I have pressed multiple Ctrl C multiple times, and I think this is a bad habit for maximum people, that they press multiple time Ctrl C. Okay, so let me run this cell. Let me run this cell, and now let's see what is the X train dot shape. Oh, sorry, what's happening? X train dot shape. So you see the X train dot shape is 353. Okay, so between 442 data, I have how much? 353. 353 data, I mean 80% data for train. And let me now see that this is test. Now I have 89 patients. So now I have 89 patients for test. Okay, that is actually the 20%. 89 is the 20% of the total. Okay, so now let's go. So now what I will do, that I have 80% data to train, so I will train the model. So to train the model, I again need the linear regression class, and I will make an instant that is LR. Then inside LR I have a function named fit. I will use the training data, that means I will use train and yTrain to train my model. Well, so if I run this cell, yeah, the training is done. And now if I want the coefficient, lr.coff and c is equal to lr.intercept. So what is the value of c? Intercept is only 153. Okay, now what is the value of m? Oh, I have 10 m's. Why? What is the m dot shape? M dot shape is 10. That means I have 10 m's. But why? I think this is because that previously I was working with one input and one output, but now I have 10 input, and as I have 10 input, and that's why I have 10 coefficients. That is because here I have made a data mx plus c. I have one input, so I have one coefficient to add with the input. But now I have 10 data, that means y is equal to m1 x1, m2 x2, m10 x10. Whoa, I have 10 data, so I have 10 coefficients, and then one intercept c. Okay, so I have found the m and c. Now let's see what I can do. If you remember that I have some test data, right? I want to test my model. Okay, so how I can test my model? Let's see that I have some output data which is y test. I have preserved this data for test, and now I will use that x test input and I will take that in the model and find something output. Let's say that is y pred. And now what I will do, you see, this y pred is not the actual value. This is obtained by the model. Model has given me that. And y test, this is the actual data. So I will compare these two with the model and with the test. That means, let's say you have a line like this, and so this the data above the point, above the line is y pred, and the data here, which is the actual value, these are the y test which you have preserved for testing. And now you have to test it by finding the difference between them, and let's see how to test that. First let me find y pred. So how to find y pred? I will do lr.predict, and I will input the test data, and I will have y pred. Okay, so I have now y pred, and now I will import from sklearn dot matrix. I will import R2 score, and now let me use that R2 score. What is this? Is it function? Yeah, this is the function. So I will use this R2 score, and this is telling me that first you input the true data, that means the y test. Okay, let me input y test, and then it is telling me to input y pred. Okay, no problem, y pred. And now if I run this thing again, let me run this thing. Okay, so my model is R2 score is 41.61. that means, yeah, good. If R2 score becomes minus or small, let's say 0.1 or 0. That time my model will be bad, but 0.41, 41%, not so bad, good. So I have made this model. So this is telling me that if R2 score is 1, that is the best line with no error. But no, that cannot be possible for the practical field. So we will try to make the R2 score near to 1, but you know that this R2 score is only 41.61. okay, that's not so bad, but you have to see that R2 score should not be less than 0, and if that is less than 0, then the squared error will be greater, and if that is 0, then okay, whatever. And this is the formula. Actually I found that R2 score formula in the probability and statistic course. Now let me see what I can do as a triple student. As a triple student, what I can do. So I can consult with ChatGPT. Let's see what I can do as a triple student with this linear regression. Okay, so as a triple student, what can I do with linear regression sklearn? Let's see what this is giving me. So it is telling me that I can use LDR light versus voltage. Yeah, I used LDR for while I was learning Arduino. So yeah, I can do that. That's good. Wow, this looks to me interesting. Diode small signal region. This looks interesting. That means what I can do, I know that the formula for the diode is IS, which is very small, then e to the power, this is actually the voltage of the diode, and VT is the thermal voltage around 25 millivolt, and N is for silicon is in the range of 1 or 2, then -1. okay, so this is the formula. And if I go to the forward bias voltage, then this term will be greater, then my formula will be become ES IS e to the power V divided by NVT, and I can neglect this minus, right? Okay, because this thing is so large with respect to 1. And so this is not the linear graph, but my intention is to find IS and NBT. So what I can do, let me take ln. So if I take ln to the left hand side, I will take ln here, so ln IS, and if I take ln here, I will get 1 by NBT into V. Okay, so now I can assume this as y is equal to mx plus c. Okay, so you see that I have made this exponential graph into linear graph, and now I have made this linear graph, and I want m and c. So what my job is, I will take some data of voltage. I have to take some data. I have to make this thing, and then I will increase this voltage, and I will measure the voltage here. I will find some data of diode, and then I will find some current, and then I will obtain this V, and I will find X. Then ln I becomes Y. That means I have the data X and data Y. And then what I will do, I will make a linear regression to find M and C, and from here C is equal to ln IS, so simply I can find IS, and M is equal to NBT, so simply I can find NVT, and I can find the equation, all the parameters of this equation. Okay, so let me see some another thing what I can do. So I can predict power, right? The input variables is temperature, hour, and what is C? Maybe C is the intercept. Okay, that looks interesting. Motor modeling, I think this is telling me about DC motor control. Okay, so a lot of things here. Okay, so what I have told to the ChatGPT that give me some sample data for diode voltage and current. So I want to train some model here. So it have give some voltage and current data, and it also give me this. So let me work with this. Okay, so let me copy this data and let me go here. Let me create another 02A. Let me call it diode.py. Okay, so let me take all the modules and print it here. Okay, and then I have the data here. So these are my data, so voltage and current. Okay, so these are for forward bias. You see that is 0.5. Okay, so now I have to model this thing. So let's see what can I do. Okay, so let me write the equation. So this is my equation. So first of all I have to find x. So x is equal to v. Okay, so that's not problem. X is equal to simply v. And now I have to find y. So what is y? Y is basically ln I. Okay, so let me write here np.log then I. Okay, so now I have to use linear regression model. Simple. So let me okay, so let me run all the thing above. Hey, what is this? Let me close this thing and let me run all the thing above. Okay, so now I will call again the linear regression class actually, and then I will lr, and then inside lr I have a fit function. I will input x then y. So I have seen some that this x is taken as capital letter. Okay, so let me take this x as capital letter also, and also I have to make this thing. Oh, it has been reshaped. Okay, thank you ChatGPT, you reshape my model without my asking. Okay, so let me run this thing lr.fit. Yeah, so this working. So now I want lr.coff, then c is equal to lr.intercept. So I think I have found the m. So m is equal to 37 and c is equal to minus 23.1. okay, so now I have to find what I have to find is and nvt. So basically c is equal to ln is. So is is equal to exponential of c. Okay, so let me make this thing. So let me make is is equal to np dot exponential c. So I think I have found the is should be very small. I don't know what is the value. Oh, 9.26 into 10 to the power minus 11. Yeah, so small. And now let me find, what should I find? Yeah, 1 by nvt. 1 by nvt is equal to what? m. So nvt is equal to 1 by m. So let me check it again. nvt is equal to 1 by m. Okay, so let me find this again, that nvt is equal to 1 by m. So if I now find nvt, so what is nvt? 26.5 millivolt. Okay, so I think I have trained I have found the ISN NVT of the diode. Great. Hey, I think these currents are in milliampere range. so I have to divide this by 100, right? Okay, so let me do this thing. Let me divide all the thing by 100. I didn't notice that that is in milliampere range. And now if I run this, and let's see what is is. Is is 9.26 into 10 to the power minus 14, and NBT may be same, 0.265 or 26.5 millivolt. Yeah, so I think now it's time to plot. So plt.plot, first is voltage and then current, and let me take those at dot. Oh, sorry. And let's see what happens. Oh, this is the exponential data, and let's set the limit. Plt dot xlim 0 to, let's say, the maximum np dot max of the voltage plus, let's say, 0.3. okay, so this is the data of the exponential graph. And now let's plot that thing. Plt dot plot v, and let me use that equation is then exponential np dot exponential v divided by nvt, sorry. Okay, so I think this is my line which is trying to fit the data. So let me remove this thing, and then again. Okay, so I think this is the data which is trying to fitting this line. I mean, with the line is trying to fitting those points. Yeah, so I have made. Let's see what can I do next. Okay, so now let's see, I want to work with Excel file, and I have pasted this data. I have told my ChatGPT to give this data, so I have copied this thing. I will copy this thing. I will copy this thing and paste it here like this. And this is current, actually current. It has given the current in milliampere. Okay, no problem. So the voltage is V and the current is I. Okay, so now let's see how to take the data from the Excel sheet and how to work with that. So I have saved this thing with diode XLSX, and now I want to take this, and you see this is along with this is in the same folder where I have the Python file. Okay, now let's see how to paste that here. I think I should make some new file. So let me make some new Python file. Let's say diode excel.py, and then let me paste all the thing, copy, and then paste this thing in the new file. Okay, now I think let me do this thing here. Okay, so what I can do, so first I will erase this data, because I will take this data V and I. So I will take this data from the Excel. So let's see how I can do this thing. Okay, so let me see. I think I need pandas. So import panda. Let me import those big fat panda as PD. Okay, so now let's use pd.read Excel, and then what I will do, I will take this name diode XLSX and copy it here, and now let's see what happens. Can it read? Oh, it's missing. What is the problem? Okay, so this is telling me that missing optional dependency. So I need to install what? PIP or conda install open. Okay, no problem. let me open CMD and let me install pip install what, that is open PyXL. okay, open PyXL. okay, so let's wait for it to download. okay, so I think it has been successfully installed, and now let's see that works or not. So let me run this thing again. Yeah, that's working. okay, so I have voltage and I have current. Now let's see how to, okay, let me make this df, and so this is df. so if I write here df dot head, let's see what happens. so it will give me just first 5 rows. okay, that's not a problem. okay, so you can see that I have v and I column. so what I will do, first I will df v, and I don't like pandas, so I want to convert it to array. so nd array, array, I have forgotten that, let me search. oh, so to numpy, so to numpy maybe, yeah, so to numpy. okay, so if I do this thing, so I will have a numpy array, so this will be equal to v, and again if I want I, so df, then I to numpy. okay, so these are my v and these are my I, so this is my v and this is my I think I is in milliampere range. I don't think so, I think this is in milliampere range. yeah, so I have to make it ampere, so let me divide it by 100 and let me make this I into milliampere. okay, so now I think it's in milliampere, and I have to fetch this b inside the linear regression model fit, so I have to reshape it. so reshape -1, 1. okay, so I think I have done this thing. so now if I run above, let's see what happens. yeah, so this is the data which I wanted to obtain, and I have done this with from reading the data from the Excel file. Now let's see what I can do next. okay, so I want to work with DC motor, so it is suggesting me that I can use this equation. actually I have learned DC motor like this. so this is the equivalent circuit of the DC motor. so this is the resistance R, actually this is the resistance of the wire, and you know that the DC motor has some back EMF which is proportional to the omega. that means this back EMF is proportional to the omega, and if you apply some voltage here, and I know that tau is equal to proportional to I think this is ideal case, but there should be some parameters here, but whatever that, I have to find the speed. I have to find the speed of the omega, and that ChatGPT is telling me that this is a actually I asked ChatGPT that is there any problem for multiple variable, 1, 2 or 3 variables. so it gives me this formula, and it tells me that omega is equal to beta naught, beta 1 v, beta 2 I, and beta 3 tau L. so that means the speed of the omega, the speed of the, I think it's a small, let me zoom it. okay, so sorry. okay, so ChatGPT is telling me that omega is a function of v, the input voltage, the current, and also the torque applied to the motor. okay, so I want some data, and I want some data. actually I didn't want some data, it gave me some sample data which is noisy, which can be obtained from the lab. so this is my data, and I have take this data here. these are so small data, 1, 2, only 10 data. no, not only 10 data, I want some more data. so let me tell him that give me some more data as table. Okay, so I got a huge data. I got a lot of data from, okay, I think it will work. So let me copy this thing and DC motor, let me delete all the thing and paste it this data. What's happening here? Let me copy this thing, this data, let me copy this table, copy, yes. Now let me paste it here. Okay, I think I have 21 data, that is enough. And this is now DC motor XLSX. Okay, so let's see. So now it is DC motor. Is it DC motor? Yeah, DC motor XLX. Okay, and now if I, let me do this thing. Oh, I think I need to, this is the data for diode. Oh, what I am doing. This is the code for diode, so I have to make another file. Let's say 04a DC motor.py. Okay, and now let me put all the modules in the new here. Okay, now I will work here. So first what I will do, I will df is equal to use that pd, that pandas, to read my excel file, and the name of the excel file is DC motor. Yeah, DC motor, small DC motor dot xlsx. Okay, so now if I run this thing and want to see what is inside df and what is the problem now. Okay, so there was some naming problem. I mistakenly input a space here. Okay, so let me give here space, and now it's okay. Now let's see what is actually df. So let me run this thing and let's see what is df. Nothing is shown. So df dot head, what, nothing is shown. Why? I think I didn't save this thing. So let me Ctrl S to save this thing, and then again. Okay, so I have many input v, I, load and speed. Let me do one thing. Let me write it only v, let me write it only I, let me write it only load. This is actually torque, not load. This is torque. Oh, same thing. This is torque and this is speed in RPM. I know that it is RPM. Okay, so now let me see df. Yeah, vi, torque and speed. Okay, so now I need those all the v. So df dot to numpy. Okay, now I will do the same thing. Wait, df only voltage, and then I will do the same thing. I will make I. Oh, I am really a dump. You see that you see that these are my inputs, V, I and torque. So I can take this V, I and torque. So let me write here V, comma I, and then comma torque. So now let's see what happens. I think I have make some name mistakenly, torque, I and speed. So what's happening? Okay, so I have to write here another third bracket, and I hope now it will work. No, it's not working. Oh, now let's see. No, it's not working. Why? Okay, so after some debugging I have done this. You see, I take the help of the ChatGPT. So these are my input columns. That means Input columns are V, I and torque, not the speed. This speed is the output, and I have taken this input column to the X. And similarly, if I want the output column, so df only the speed is the output, right? So speed, and I want to convert it to numpy. Okay, so let me do this thing, and again s is, I think s is capital, right? No, that's not working. I actually understand. Actually there is a little space, there is a little space, so I have to remove that, all the space here. Oh, I have some space here, and that is causing the problem. So I am deleting all the unwanted space. Then let me copy, then let's see what happens. I think now it should work, but no, this is not working. Yeah, now it works after renaming the column. Now it works. Okay, so I have input, I have output. So now it's time to linear regression class, and then I will make a LR named object, and inside LR I have fit. I will fit X and Y, and yeah, it works. And then what I will do, I will find the lr.cof, which is actually M, and then I will find the lr.intercept, which is actually C. So M is, as there are 3 input, I have 3M, and C is 356. That means my equation looks like this, and this beta 1, beta 2 and beta 3 is the coefficient, and this beta naught is the intercept. So now if I try to find the work with new equation, sorry, new data, let's say lr.predict, okay, so I will insert here new data, and my new data will be let's say np.array, voltage is, let's say 20 volt, current is in milliampere, right? So current is in milliampere, let's say it's 0.5 milliampere, and torque, let's say 0.1, let's say. So what will be the speed? Let's see. And I have to reshape it, and why it's giving error? Okay, so I have to make it 2D array, so that's why I have to make another bracket here. I'm sorry, I think I should not use here reshape. I think I have previously used here reshape, but I'm sorry for that. I shouldn't have used their reshape, rather I have to make this in 2D. Let me show you what. If I remove those brackets, and then if I see new data dot shape, so this is 3,3, and now if I give here bracket, and let's see what happens, and new data is 1,3. so what is actually new data? So new data looks like this kind of matrix, like this array, and this looks like matrix. If I write here type new data, so numpy.nd array. Okay, so now let's work with, so what is the lr.predict? So it's predicting me in that 2131 rpm. So I have input voltage, current in milliampere and torque, and now it is giving me the rpm rotational speed. Hey, I think this equation is not correct. I think this equation is not correct, because I have learned that this is resistance and this is the back EMF k phi omega induced in the DC motor, and this is the voltage applied. So we know this is I, so V is equal to IR plus k phi omega, and torque is actually k phi I. So I is equal to tau by k phi omega. So I think this is actually the formula. So omega is equal to P divided by k phi minus tau divided by k phi square. I think the formula looks like this. I don't know why ChatGPT has used this formula. I don't know, but that's okay. We were here to make a linear regression model like this, and we made it. And now let's see what we can do next. Okay, so this is my graph. Actually, I was printing torque versus speed graph, and this graph looks like this. So the lines are not aligned with the points, but trying to catch that points, I mean approximate line actually. Okay, so now let's work with Hall sensor. Okay, so I have asked ChatGPT that what can I do, so it is telling me to work with Hall sensor. Okay, so let's do. So if you can remember how this Hall effect, I think you should know, if you know the physics, that what is actually Hall effect. So Hall effect is basically if you apply a magnetic field. Let's say the magnetic field's rotation is this towards you, and let's say the electron is flowing in this direction, then this will, I mean, let's say the electron is flowing in this direction. Okay, so this will got a force, so this will get a force, it will get a force downward. That means this electron will gather here, another electron will be gathered here, so this electron will gather here, and that means there will be some lacking of the electrons. So here you will have a positive voltage induced here, and now if you measure the voltage, you will get the Hall voltage VH. Okay, so this is actually the concept. So we have to find the VH. I think here we have to find the Hall voltage VH, which is the function of B, the magnetic field, current, okay, temperature, and BCC. What is BCC? The applied voltage maybe. Okay, so I should ask ChatGPT to give more and more data. So give more data, more for multivariable Hall sensor. Okay, so I asked multiple data. Let's see what happens. Okay, so let me copy the data. Yes, it's copied. And then let me go to here, and now I will make an Excel file, Microsoft Excel, and let me name it Hall. Okay, so now I will make another file here, 05 hall.py. Okay, so now I will take this module again and use it here. Okay, so now let's see. Okay, so again df is equal to, I will use this panda to where is my Hall? So this is my Hall. Let me remove this thing, save, then again let me cut this thing, save, now Hall. Okay, so now let me again copy this thing, Oh, I think this is copied already. Now let me go here and let me paste this thing here, and I have 31 data, and I think I can work with this 31 data. Let me save this thing. Okay, so now pd dot read excel. So pd dot read excel, then I will have whole xlsx. So I think this works. Then df dot head. So I have input magnetic field, current, temperature and supply voltage, and I have the output hall voltage. Okay, so I have to take input x. So what is actually my goal? I want to make a model where Hall effect will be input and beta naught, beta 1, all the outputs. Let's say first output is B, then another input is I, another input is BCC. So my goal is to find B naught. This is actually the intercept, and I have 3 coefficients as I have 3 inputs to stay with them. Okay, so let's see. So I will take x. So what will be x? So x will be from df, but not all. I will take df dot columns. Okay, and I will take only magnetic field, current, temperature and supply. Oh, I have 4. Sorry, I have actually 4. I also have temperature. So 4 coefficients. So what I will do, from 0 to last, I means from 0 to supply voltage 1 2 3 4, this 4 columns data will be inside x, but I don't want this x into pandas form. Instead I want it to numpy form, and let's see what happens. Okay, so if I now click here x, so I can see that x has all the data in the as numpy form, 1 2 3 4 columns. And if I see the x dot shape, I will see that 30 rows, 30 data and 4 columns for 4 input. And similarly I have to take y. So what is df actually? So so df dot head. So I have Hall voltage at the last, so df is equal df. Okay, so similarly I have take y as output. Now I have to do the same thing. LR is equal to linear regression, and then LR dot fit. I will take x and y, and then I will get I have fitted the model, and thus I will have the LR dot intercept and LR dot coefficient. Actually this is C, intercept, and M is the coefficient. Okay, so C looks like this, M looks like this. And now I want to predict something, so let's see, LR dot predict. So let's say what I will do, let's see that df dot head. So I have magnetic field in millitesla. So let's say the magnetic field, don't forget to give here 2 third brackets. So let's say magnetic field is between 10 and 15. Let's say it's 12.5. Then let's say current is let's say 0.6 ampere. Then temperature is, let's say, 30 degrees Celsius, and supply voltage, let's say 10. And now let's see what is the voltage. So the voltage is 27 volt. Okay, and what my data looks like. Yeah, and now I want actually to plot these things. Okay, so now let's see how is my model. So y pred, how my model looks like. So lr.predict, then I input all the x, then I will get the y pred. That means let me y from model, okay. So I obtain this y, that means the output, actually this is the Hall voltage. Let me write here Hall voltage. The output is Hall voltage, so Hall voltage from the output. And now let's say I want to draw something. Okay, so what I can draw, let's say I want to draw the magnetic field versus Hall effect. Well, so let's see.